This is Using Genetic and Traversal Algorithms to Optimize Shipment Routing by Jonathan Turner and Sarah Crosby. For the background and significance, every day millions of shipments are sent across the world. It is important for shipping companies to be efficient to handle the large amount of packages they process. While there are many navigation systems designed to efficiently find a path from point A to point B, shipment routing requires multiple stops. We wanted to implement different algorithms to see which one was the most effective at planning a route for package delivery. We implemented A*, uniform cost search, best first search, and genetic algorithms. For related work, our first work is using AI and ML to predict shipment times of therapeutics, diagnostics, and vaccines in e-pharmacy supply chains during the COVID-19 pandemic. This was a study where they used k-folds to train base models and then used those models to train meta models to predict delivery times. They achieved a 93.5% accuracy rate on delivery times. Our next work is travel time prediction with LSTM neural network. The study used long short-term memory neural networks to estimate travel times and ended up with a median of their mean relative error of 7%. Our last related work is science-based AI model certification for untrained operational environments with application in traffic state estimation. The study trained an AI to study traffic based on fluid dynamic principles. The lowest error rate they achieved was 17.81%. For our methods, we took nodes and designated some nodes as distribution centers and the rest as potential sources/destinations for packages. We gave these nodes connections and designated those as local or distribution routes. Each of these connections represented the path a shipment could potentially go on. To better represent this, each connection was given a range of weights it could be, with local routes having more weight and therefore being less efficient. We used this to implement genetic algorithms A*, uniform cost search, and best first search to see which algorithm was able to find the most efficient shipment route. For our algorithm description, starting with A*, A* is typically known as one of the best path finding algorithms. It considers the cost of the current path and the heuristic to find the node with the lowest path. Our second algorithm is uniform cost search. It's a special form of A*. It does not use heuristics. It functions by exploring whichever node has the lowest cost. Best first search uses a priority queue to explore nodes with the lowest cost first. It uses heuristics to try to predict how close a node is to the goal node. Genetic algorithms use multiple generations of data to find the optimal solution. So for our data sets, our genetic algorithms took 25 milliseconds to solve and had an average weight of 985. This was the lowest weight, but it took the longest to solve. The next one is A*, which took 9 milliseconds to solve, but had a weight of 1,429, which was the highest weight. UCS had a weight of 1,067. It only took 4 milliseconds to solve, and BFS took 0 milliseconds to solve and had an average weight of 1,132. In conclusion, our genetic algorithms found the most efficient path out of the algorithms tested, but BFS is the fastest algorithm of the ones tested. Even though genetic algorithms take longer, the route is the most efficient. This indicates that they would be the best option of those tested for routing shipments. However, more testing would need to be done on a larger scale to confirm these findings. And here are our references.